Hey guys, I'm back with a new video. In this video, let us learn about the spread operator in JavaScript. Now, one of the convenient syntax features that were introduced in the language was the spread operator. Let us dive deeper into that. The spread operator is an operator that pulls out all the elements of an array and will give them to you as an independent, cloned, standalone list of elements. Now, you can make use of the spread operator to make a shallow copy or a shallow clone of the array. If you don't know about the concept of shallow and deep cloning, the link for a video on that can be found down below. Now let us define an array of nerds and I will show you how we can make use of the spread operator to make a copy of it. So spread operator, I will define an array of nerds. So scene, the nerdy dev. Okay, I can't type. Alex, Rishi, and then I will log the nerds to the console. So back in my browser, you can see we are getting the simple array of 4 elements. So that is something we already know. Now, to make a shallow copy or the clone of the nerds array, we have a couple of ways to achieve this. Now let us see how we can achieve this using the spread operator. So I'll define a new constant and I will name it as nerds copy. So const nerds copy, and I will use the 3 dot syntax and then I will append nerds here. Okay, so you can see this 3 dot syntax which you are seeing is called as the spread operator. The interesting thing is that if I mutate the copy of the nerds array now, which in this case is the nerds copy, the changes will not get reflected in the original array. So if you're trying to mutate the nerds copy, since you are making a copy from the original array, from the original source will not get mutated. Only the copy will discover those changes or will observe those changes. Okay, so the nerds array will remain intact if we directly mutate the nerds copy. So let us use the push mutator method on the nerds copy and add a new element at the end of the array. So I will say, so now I'm directly mutating the copy and I'm pushing a new element to it, say changed, and let us log the nerds and nerds copy to the console. So let us go back to the browser to see the output. Now you can see our copy got mutated, but the original source of data is still intact. It didn't discover or didn't observe those changes. Those changes are only reflected in the copy and not in the original array. The reason behind this is because we are directly mutating the copy by using the push method. Okay, so this is one thing that you need to understand. Now as you can see from the output that we got in the console, the original array remained the same, and the copy of the array that you created using the spread operator, you directly mutated that. So the original array is left untouched in this case. So therefore, if you're trying to add a new element to the copy array, or even if you did the same on the original array, then the copy would have remained unchanged. So here I mutated the copy, so our original array did not got mutated, because we are directly mutating the copy and not the original source of data. So the copied array, which is the nerds copy in this case, it got mutated, and both of them are different arrays sitting at the very different memory locations. Now let me show you one more example of spread operator to make this clear. So given a list of numbers, we want to find the minimum number from that list. So what I will do is, I will say const numbers 1, 2, 3, 4, 5, 6, 7, 8, 2.2, 0.5. And if I now make use of the math global object, so we have a math global object in JavaScript for numbers, and on that object we have a min method which takes in a bunch of numbers separated by commas and not an array. Okay, but the problem is that if we pass numbers directly as an array to the min method, it will give us none. Let me show you this. So I will say console.log you can see we are getting nan. Okay, so this was not the expected output. We want to get the minimum element out of these bunch of values that we have passed to the min method. But this is taking an array, and for an array it cannot say which number will be minimum. You have to spread these numbers using this spread operator. So this will basically give us a standalone list of elements separated by commas, and then we will be able to use the min method. So if I do like this and go back to the browser, so we will get 0.5 as the answer, which is correct. Okay, so this gives us the correct output. So what this did was, it took the array of numbers, pulled out the comma separated elements that we have in our numbers array, which you can see here. So it pulls out all these elements, okay, and spread that to the min method. Now the min method has achieved these elements, so it basically got these elements, and these elements are fed to the min method, which was exactly what we wanted to achieve to get the correct output. Now one gotcha is there in case of spread operator when you work with objects, and that is indeed a downside to using the spread operator for an array of objects. What I will now do is I will create an array of gamers. So I will say const gamers, and I will define an array of games. So I will define some objects here. I will say name the nerdy dev and is gamer true, then name scene is gamer true, and then name Rishi is gamer false. So we have defined an array of gamers. So now if I try to copy the array of gamers using the spread operator, so I will say const gamers copy, and using the 3 dot syntax I will say gamers. And now if I push a new gamer to the gamers array now by saying gamers dot push, and I will add a new object, I will define a name property on the object as anonymous, and then is gamer will be set to false. And now if I log gamers and gamers copy to the console, and let us go back to the browser to see the output. Now you can see that we are getting 4 elements in case of our gamers array, because the gamers array was directly mutated when you add a new element to your gamers array, but the changes are not reflected in the copy because we directly added a new element to the original array and not on the copy. So it did work exactly the same way as we wanted it to work. Now one common mistake is to think that objects in the array which are also reference values, they are also copied, and that is not the case. You are copying all the elements of the array, which means that we are copying all the addresses of these objects in the end. So even if we have a copy of the array, the objects in the array are also the same very old objects. Again, you should never forget you are working with the reference values, and therefore the array of gamers in the end is an array full of addresses to the places of memory of these objects. So in gamers copy, you are copying all of these addresses here, and hence if you go to the gamers array and change the name of the very first gamer, so name of the very first gamer, which is the gamer 0, and I will say dot name the nerdy. Okay, so what was the first gamer? The nerdy dev. Okay, and if I log this to the console, you will see this change will also get reflected in the copy as well, because we copy only the addresses of these objects, okay, and not the complete object. So I will say gamers and gamers copy, and let us go back to the browser to see the output. Okay, so now you can see the original array did got mutated. It had to, because we directly changed the name property of the gamer 0, But if we see the copied array, which is a clone array, it also did got mutated. Okay, isn't that interesting? So the reason of this is that because we copy the address to the place in memory, and here we change the name of the very first gamer we edited at that place in memory where this gamer was sitting, and the gamers and the gamers copy is actually referring to the same object in memory. Okay, so we're not copying the gamers array, gamers objects that we are having, we are just copying their addresses. So both of these arrays are having exact same objects in them. Okay, so we are copying the addresses to the place in memory, and here we have changed the name of the first gamer we edited at that very place in memory where this gamer, which is representing this object. So if we try to mutate it using gamers or gamers copy, because this object is having the same address in memory, so it gets mutated in both the arrays, and both the arrays reflect the same very state. Okay, so when you are changing the name of the first gamer we edited at that place in memory where this gamer was sitting, to conclude any edits to the gamer objects will get reflected in the copied array as well, because even though you create a new array using the spread operator, the objects are exactly the same, because you're not copying the objects and their properties but just their addresses. Okay, so if you want to copy the gamer objects as well, you can achieve this using map method. For example, let me show you this. So I will say const gamers copy along with copied objects. So now we are not just copying, in this example which I'm going to show you, we are not just copying the addresses of these objects, we will directly deep clone them. Okay, so now if we will be making this cloning which we are going to implement, the gamers objects will be entirely different. So one object will be sitting at different memory location, another one will be sitting at different memory location. Okay, and the changes will not get reflected in each of them, so they will be independent, and that is what we want to achieve. So I will say gamers.map, and for each gamer I want to return, and now we can return a new object for every person. So I will say name, and I will say gamer.name, and gamer, I will say gamer dot is gamer. Okay, better would be to change this to is gamer as well. So gamer dot is gamer, and what it does is we use the same data for the gamer object. Okay, so the gamer object will have these two properties, name and is gamer, and we are using these properties, and it will basically make use of the same data for the gamer object that we had in the original games array, but we wrap that into a new array. So we can copy to any level of nestings in our objects. So if I now log the gamers copy along with copied objects, and if I directly make some change on the gamer1.name and now log the gamers and gamers copy along with copied objects to the console, let us go back to the browser to see the output. Okay, so as you can see, okay, so scene changed. Okay, because it was already seen. Okay, so you can see the gamer1 which was sitting in the gamers array got changed. It got changed to scene changed from scene. Okay, so let us check whether the gamers copy along with the copied objects got mutated as well. So for the very first gamer, you can see it didn't got mutated because we are now able to successfully copy the object as well. Okay, so we are not referring the same object that is sitting in the gamers array. We made a complete copy or a deep copy of that object. So if you haven't still understood the concept of shallow and deep cloning, I would definitely recommend you to check out my video on shallow and deep cloning. The link for that is down below this video. Okay, so this way we can achieve deep cloning in objects. So you should only copy what you plan on changing, where you don't want these changes to be reflected in the copied array. In the end, the spread operator is a very important tool for copying, distributing elements into an array. And when you do make a deep clone, keep in mind that the nested object references which you might need to copy as well. You don't want the changes that you introduce to these objects to get reflected to the newly created references, like we just did. Okay, so this was all about the video on spread operator. So in the very next video, I will discuss about maps and sets, and then we will proceed with objects and object-oriented programming. So if you liked the video, do give it a thumbs up, and please guys, do share the channel with your friends and colleagues. This would give me fuel to keep bringing such content. So please become the source of my motivation, and also you can find the link of our Discord server down below. So let us catch up in the next video.